Okay, so what we're going to look at today are different characteristics that a graph can have. So we looked at domain and range last class, and now we're going to look at the rest of them. One of the things that we can have are intercepts. X-intercepts are where the graph touches the x-axis. So remember, the x-axis is here. It goes from left to right. In this example, we have two x-intercepts. There's two places where the graph touches the x-axis. Intercepts are points, so we have to write them as coordinate points. They're not just numbers. Any x-intercept will have a y value of 0 because we have gone 0 above or below the x-axis. With a y-intercept, it's where the graph touches the y-axis, so that's the one that goes up and down. There will always be a 0 for the x, and then we want where the y-axis touches the graph. So in this case, our y-intercept is 0, -3. In this next example here, our x-intercept is at -1, 0. We only have one of them. We might have no x-intercepts, we might have one, we might have many. It just depends on the graph. So if you don't see an x-intercept, that's completely okay. Sometimes the graph won't touch it. The y-intercept is over here at 0, 1. It is important that when we write points that we always go in the order x, y, because the point 0, 1 is different from the point 1, 0. Those are in two different places. Sometimes your graph might look like this. So if the x-intercepts aren't great, like this one over here, will let you know kind of what that point is. So if you need it for domain, range, intercepts, you'll know what number it is so you don't have to guess. So this one has 3 x-intercepts. And a graph will only ever have 0 or 1 y-intercepts, otherwise it's not a function. It is okay for there to be the same point on the x-intercept as the y-intercept. So if it's 0, 0, it's both x-intercept and y-intercept. So it's okay for that point to appear twice. Minimum and maximum are what are known as extrema. Those are high in the case of a maximum, or low for minimum points on the graph, it will make a shape kind of like that for a maximum. So like that 0.41 there. Or it'll make kind of that shape. And we want the point at the very bottom or the very top, depending on what exactly, whether it's maximum or minimum. If it is the highest point on the entire graph, like how 4,1 is, then in that case, it is an absolute maximum. If we had something kind of like this, where it goes down and back up, it goes higher than this point when we get over here. So this would be a local maximum because it is the highest point in that area, but we do go higher later on, so it is not the absolute biggest point on the entire graph. In this case, there is a maximum and no minimum. So if a characteristic isn't there, just write none. For number 2, we don't have a maximum because the graph is going to keep going up forever. However, we do have a lowest point. So we have an absolute, because the graph never goes below that, minimum at -1, 0. Over here, we've got a minimum. We have an absolute minimum at -1.781, -4.409. We also have a local minimum So we could have no minimum, we could have just an absolute or just a local, or we could have both. So it depends on the graph you're given. But for minimums, you're looking for that U or V shape. And we want the bottom of those. Again, for maximum, we're looking for more like the top of a hill or the top of a mountain. We do have one. This point is very popular here because it does go up and then slightly back down to create that local minimum. So 0, 0 again. With the vertex and the axis of symmetry, it depends on what kind of graph we have. These two will only be on absolute value, which is that V shape graph, or a quadratic, which is the U. So if it is not just a V shape or just a U shape, we don't have these two characteristics. The vertex will be the absolute maximum or absolute minimum of that graph. So in this case, that's the point 41. So okay, apparently I'm not going to erase that. So only those two types of graphs are going to have these. So vertex is absolute maximum or absolute minimum. The axis of symmetry is an invisible line that cuts the graph into two pieces that are mirror images of each other. So like how these two lines look the same, but they're going in opposite directions. That's what the axis of symmetry shows us. Because it is a line, it is an equation. We will always have x equals, and then it's the x value from the vertex. Every single time x equals, and then whatever the x value of the vertex is. This is not a quadratic or absolute value, so it's not going to have either of these. If there is no vertex, there is no axis of symmetry. And same thing here. So even though it has that U shape as part of it, this isn't quadratic, which is just a U, no other squiggles going on. And it's not an absolute value, which is just a V with no other squiggles. So there's no vertex or axis of symmetry. This one does, because this is what a quadratic looks like. So number 1 is absolute value, number 3 is quadratic. So if it does not make one of those two shapes, and it could be, right side up V or upside down, right side up U or upside down. If it does not make one of those 4 shapes and one of those 4 shapes only, so no going back or forth, has to be one of, don't know why I want to erase. There we go. If it does not make only that shape on the entire graph, no vertex or axis of symmetry. This one does. So the vertex is at our minimum. So that's an absolute minimum because it is the absolute lowest place on the graph. Axis of symmetry is going to be x equals and the x value from the vertex. Okay, we'll do more like this in class. Those are the characteristics along with domain and range that you need to know. On your test, if it does not specify what characteristics to identify, check for all of these in domain and range. If you don't have something, that's completely fine, but just check for all of them and identify the ones that are there. And there we go.